Today we're going to be looking at finding the percentage of water of crystallization in hydrated iron sulphate. Now, water of crystallization, this classically refers to water which has been retained within the crystalline framework of a metal complex but is not chemically bonded to that metal ion. A salt which is associated with this water of crystallization is known as a hydrate. Unfortunately for us, this hydrate can be heated and this water of crystallization can be removed. So how are we going to calculate the percentage of water of crystallization within our sample of hydrated iron sulphate? Well, what we're going to need is a weighing balance, a calculator, a crucible and lid, some weighing bolts, hydrated iron 2 sulphate, a tripod, pipe clay triangle and Bunsen burner. Now, before we start the experiment, we should obviously be aware of the safety aspects, so we're going to wear our lab coat as standard to protect our clothing. We've got our safety goggles, which we're going to wear throughout the experiment to protect our eyes, and we're also going to use tongs as the crucible is going to be very hot and we want to avoid being burnt. So the first thing we're going to do is measure out 1.3 grams of our hydrated iron sulphate solution, as so. As you're weighing the iron sulphate, have a look at the initial colour of the hydrate. As you can see, a baby blue colour. Just make a note of that. Following that, you're going to zero the weighing balance and measure a crucible and its lid combined. And you're going to record this weight. Once you've got those weights recorded, you're going to transfer our hydrated iron sulphate into an empty crucible. Place the lid on it. We're going to place it on top of the pipe clay triangle and apply a gentle heat for 2 minutes. As previously mentioned, we're using a gentle heating, as otherwise strong forceful heating will cause the iron sulphate to decompose and it could pop like popcorn. So after 2 minutes, being careful not to touch the crucible, as obviously it's going to be quite hot, we're going to use our tongs. Just lift the lid off and check the colour of the hydrate, see if that's changed at all, if there's any changes there. Whilst conducting the experiment, you want to try and avoid the production of brown iron 3 oxide, like as you can see here, if possible. Now, when you're heating the crucible, you want to use the orange flame and heat it gently. Now, the reason we don't want to use the blue flame is to prevent the hydrate, in this case the iron sulphate, popping like popcorn, and that will cause the hydrate to decompose.
But wait! There's more! Hang on to your seat, baby! Cause this one's a screamer!
Gentle heating of the crucible should be stopped if white clouds are produced. Now, these white clouds are going to be sulfur trioxide. This is the primary agent in acid rain and can cause serious burns on inhalation and indigestion.
That's a spicy meatball!
It's also highly corrosive, so if these white clouds are produced, just shut off the bouncing straight away. After allowing the crucible to cool, we're going to carefully lift it off and place it all into the balance and weigh the lid, the crucible and its contents again. And once again, you're going to record that weight. Once that's been recorded, you're going to return it to the tripod, apply a gentle heat again and repeat the process for 2 minutes. Again, you just want to check the crystals, see if a colour change has taken place. Now, once that's been allowed to cool again, we're going to carefully remove the crucible from the tripod, place it onto the balance, and we're going to weigh that, record that weighing again. When a constant mass is observed, that is when we know that all water of crystallization has been removed and we have what is known as anhydrous iron sulphate within the crucible. With these results, using your calculator, you should be able to calculate the weight of water given off from the hydrated iron sulphate. Should be able to calculate the mass of the anhydrous iron sulphate which was formed after heating. And finally, you should be able to calculate the percentage of water of crystallization which was held within the framework of the hydrated iron sulphate before we heated it. On completing this experiment, you're now able to accurately measure masses. You're able to successfully heat a hydrate to remove the water of crystallization without decomposing it, and you're able to calculate the water of crystallization present within a substance. Well, I've been Simon.
And in case I don't see you, good afternoon, good evening, and good night.